Hello students, welcome to Web Studies, and today we will be covering Pascal's law under the chapter Mechanical Properties of Fluids. This is a very important concept for JEE Mains and Advanced. So what does Pascal law says? So according to Pascal law, a change basically in pressure which is applied to an enclosed incompressible fluid is transmitted undiminished to every point of the fluid and the walls of the containing vessel. So mathematically we can write PA is equal to PB equal to PC. So here P is basically pressure, but what is this A, B and C? So here A, B and C, they basically mean that the pressure at any point A, it is equal to pressure at any other point B, similarly equal to pressure at any another point C, as long as they are connected by a rigid boundary and also the fluid, it is incompressible. Fine. Now, what is the importance of studying this? So, its importance is basically reflecting in the design and the operation of efficient hydraulic systems like bridges and all. Apart from that, prediction of fluid pressure distribution and also the flow patterns like turbulent or laminar. Also understanding buoyancy and Archimedes principle. Now, what is the application or what are the applications of Pascal's law? So, firstly, hydraulic systems. Pascal's law is the basis of hydraulic system such as hydraulic lift, pump, cylinder, where pressure is transmitted through a fluid so as to amplify or change the direction of force. Secondly, we can say buoyancy. So this explains why object they experience an upward force, that is buoyancy, when partially or fully submerged in a water, or we can say fluid, as the pressure changes is transmitted equally through the fluid. Third is hydrostatic pressure. So this law, it helps to understand hydrostatic pressure as well, which is the pressure exerted by a fluid at equilibrium due to its weight. Fine. Now let us see the derivation of our Pascal's law. So kindly observe this figure. Fine. As shown in this figure, we have to consider a small element ABC and DEF in the form of right angled prism in the interior of the fluid at rest. The element will be so small that all its parts can be assumed to be same depth from the liquid surface, and therefore the effect of gravity will be same at all the points. So suppose liquid exerts pressure PA, PB and PC on the faces BEFC, ADFC and ADEB, fine, respectively, of this element. So corresponding to normal forces, these faces will have force FA, FB and FC, and similarly we can say the cross section area AA, AB and AC on these three faces. So in right triangle ABC, angle ACB, we can refer this as theta. So as this element is in equilibrium, we can equilibrium with the remaining fluid, the force should balance in all direction. So we can make diagram for this representing the angle. We can make the diagram. So this will be like this. So in this direction, here we will have theta. This will be FB cos theta. Why? Because this is our FB. Similarly, this will be FB sin theta. So along the horizontal direction, we can write FB sin theta equal to FC. Also, we can write FB cos theta. This will be equal to FA. Fine. From geometry of the figure, we can get that AB sin theta, this will be equal to AC. Similarly, AB cos theta, this whole thing will be equal to AA. A basically here is cross sectional area. So from these four equations, fine, we can have a conclusion, that is FB upon sin theta by FB, or we can say AB upon sin theta, this will be equal to FC by AC, and FC, or we can say FB cos theta by AB cos theta will be equal to FA by AA. So here in these both side, here sine and sine will get cancelled out, here cos and cos will get cancelled out. So if we carefully recognize this, the final result we are going to get is FA upon AA equal to FB upon AB. This will be equal to FC upon AC. Also we know that pressure is equal to force by area. So this is ultimately equal to pressure at A equal to pressure at B equal to pressure at C, which is our final result of this derivation. So since we understood the derivation, now we can solve a question based on this for better understanding. So the question is, given a hydraulic press has a ram of 30 centimeter diameter and a plunger of 4.5 centimeter diameter, then what is the weight lifted by the hydraulic press when force applied at the plunger is 500 Newton? Fine. So diameter is given here. So diameter of the plunger, let's take it as small d. So this is 4.5 centimeter. Fine. Also, diameter of ram. Take this as capital D. We will have as 30 centimeter. Fine. Now force applied at plunger, we will take that as F1, let's say. Fine. So 500 newtons. Now, according to Pascal's law, pressure applied at plunger, we can refer this as P1, is equal to pressure exerted on the ram. Let's say it as P2. So pressure is force upon area. So F1 by A1 is equal to F2 by A2. Fine. Let us put the values. So F1 we have as 500 newtons. Fine. So area in terms of diameter we can write as pi into d square small d by 4. This will be equal to F2 divided by pi into capital D square upon 4. Now, if we substitute the values of the small d and capital D, we are going to get the next expression we will basically get F2 is equal to capital D, that is 30 square, divided by small d, that is 4 point square, into we will do 500. So if we calculate this, we are going to get 22,222.22 Newton. Or if we calculate or convert this into kilonewtons, we are going to get approximately 22.2 kilonewtons, or we can directly write 22 kilonewtons, Kn. Fine. So I hope you understood this question and the concept of Pascal's law as well. Thanks for watching this and thank you.